Hello children, let's understand this very important concept of matter. Children, how small are these particles of matter? So how can we find out that particles of matter are very small? So for that, we should know that the size of particles is so small that it is difficult for us to comprehend. We cannot comprehend the size. It's so small, it's so tiny that even you cannot hold it. If I ask you bring one particle for me, no, it is not possible for you. You can't bring one particle for me. So children, the size of the particle of matter is so small that it is difficult for us to even comprehend. So what are these? These are the particles of matter. But can you guess which one is solid, liquid and gas? So children, solid, have you seen solid? These are solids. The particles are so tightly packed such that they have a rigid structure, right? A fixed shape. It has a fixed shape. It has a fixed shape. I have a fixed shape. I am solid. So the particles in the solid, they have fixed shape because they have fixed arrangement such that their particles are very close to each other. So these are solids. What about this? The particles are little far away from each other but not very loosely held. So this is liquid, right? And what is this? The particles are loosely held and they even try to escape from the container because this is gas. But they all contain particles and these particles are very small. Do you see particles in water? No, I can't see. Do you see particles in this? No, I can't see any particle in this. It's just it has a beautiful grey color with black nib, right? But I can't see any particle in it. I can't take out a particle from it because it's so small that you can't even see from the naked eyes. You definitely need a microscope to even visualize the particles. So children, solid, liquid, gases, they all contain particles in certain arrangement, but these particles are very small in size. So there must be an activity to prove that the particles are very small in size. So the activity is there are millions of tiny particles present in matter. Millions of particles, right? So what do we do in the activity? We will first of all dilute the solution of potassium permanganate. Children, potassium permanganate is KMNO4 and it is beautiful dark purple coloration crystals. So we will take 2 to 3 crystals of potassium permanganate, that is KMNO4, and we will put it in 100 ml of water, right? So take few crystals of KMNO4, these are dark purple colored crystals, and put them in 100 ml of water. So this is the dark color solution you will get. So as you can see, it is a dark purple color only. It's 100 ml water. Now take 10 ml of this solution and that 10 ml is poured in again the remaining 100 ml of water in another beaker. Now, do you see the change in the color? Why? Because we have added more water to it. So there is dilution going on. What is the meaning of dilution or dilute? Children, dilute means we are adding more water. So we are actually taking 10 ml of this solution and that 10 ml we are pouring it in another 100 ml of water. So is the water content increasing? Yes. So that's why I'm saying we are diluting the solution, means we are increasing the content of water. Now the color is different. It is not dark purple. It is sort of magenta, right? Now take 10 ml of this solution and put it in another 100 ml of water. See, the color is again changing to pinkish. Now take again 10 ml of this solution and put it in the next 100 ml of the beaker. So see the water color. The color of water is again changed. It is very much light pink in color. So the question arises, what is happening here? Why there is a change in color going on and why the color of KMNO4 is not disappearing? Right? We just added 2 to 3 crystals of KMNO4. But still, see, we do have a color, some color. It's not a colorless water now. When we poured this 10 ml to the water, the particles should have gone. But no, you can see the particle colors even here also. The color has not vanished. So why is this so? So can I say the observations are on adding more water to the solution of potassium permanganate, the color of the solution becomes light but still visible, right? Do you still see the color? Yes. So the color is still visible though it is light shade now. So what is the conclusion? So can we say that each potassium permanganate crystal consists of millions of minuscule particles that can continuously divide into smaller and smaller particles. Is it so? Yes, because we just poured 2 to 3 crystals in this 100 ml beaker and see how intense the color is. It means the crystals have lot of particles such that when you put them in water, the millions of the particles, they segregated or they spread all over the water. And then when we taken out 10 ml of it and poured it in other water, again those particles spread out throughout the water. Then we took that 10 ml in the another beaker containing 100 ml water. Again, the particles, they spread throughout the water. Again, they spread out throughout the water, but particles are still there. So it clearly indicates that there are millions of minute or small sized particles that continuously divide into smaller and smaller particles. Hence, we can say that there are tiny particles present in matter. I hope you have understood. Thank you.